Hi, everyone. This is our final review, literally our final review. And this is going to be on equations. So the final is going to be on two portions. And this portion is on the equations, just solving equations. So if you look at an equation, like let's say for number one, you should be able to tell, how can I solve this, right? And so over here on the right-hand side, I wrote down what each of the sets of problems are going over. So 1 through 8 is going over exponentials. 9 through 16 logs, then quadratics, radicals, then rationals, and then radicals again. Don't ask why I put radicals in two different places. Just know that that is what it is. So if I can learn how to like tab the different places so you can see, like bookmark each section. If I can learn how to do that, I'll do it. And if I can't, I can't. You figure that out. You can do that yourself, right? So we'll start from problem one again. It will really benefit you if you do these yourself as far as you can, and then you come and play the video, or you can watch it first and then try them yourself. But if you're not giving your brain a chance to actually do them yourself, that's not a good idea. There's gonna be no retention because you're not actually learning, you're just watching, you're being passive. So as much as you can be active about it, do that, find what works best for you. Some people like to copy down all the work first, then watch the video again to kind of just process the information, and then you could try it again. So if you need like two packets, let me know, or you can just print it out from Canvas. All right, let's get started. All right, so number one, we have definitely exponential. And notice I have these bases that are, we have exponents on both sides. So I'm thinking, okay, the bases are both 4 and 8, and I know there are multiples of 2. So I'm going to do the same basis for these ones. So I'm going to change this to a common base of 2. So that's 2 to the 2 power, because 2 to the 2 power is 4. And then so 2 to the 2 power, and then that exponent right there, so 3 to the 3n times, again, 4 is going to be 2 to the 2 power. So we're just changing the way it looks. And so instead of saying 4, we're just saying 2 to the 4th power, 2 to the 2nd power. And then -1 equals 2. And then this is going to be, instead of 8, we're going to put in 2 to the 3rd power, because 2 times 2 times 2 is 8. Don't say 6. That's bad days. All right, so -n minus 3. Right, now we have that, we're going to use the exponent properties. So we know that power to a power means that we're going to be multiplying these. So this is going to be 2 to the 6n times 2 to the -2n is equal to 2 to the 3 times -n, which is -3n, and then 3 times -3 is -9, so -9. All right, so and then notice here we still have these two bases here, so we're going to have to do something about it. We need only one base, so we want exponents of bases on both sides, just one base on each side. So whenever we're multiplying the bases, we're going to be adding the exponents. So that's actually 6n plus -2n, which is going to be 4n. And that's going to be equal to 2 to the, well, there's nothing else to combine here. We'll just leave it like that. So now once we have the same bases, those exponents have to equal each other. So it's going to be, so we're going to be like, here's my highlighter. So this guy right here has to equal this guy right here. So we're going to write down 4n is equal to -3n minus 9. Let me just highlight that so it's the same colors. So you can see, oh yeah. Okay, so we're saying those exponents have to be the same, right? That's the only way it's going to be equal to each other. All right, and then now it's just algebra 1 stuff. We're just basically just solving for n. We're going to get the n's together. So I notice that I have my constant here, and I do not have a constant over here, but I do have n's on both sides. So I'm going to take by -3n to the left-hand side. So I'm going to add 3n to both sides. That cancels out, and we get 7n is equal to -9. And then from there, what are we going to do? Divide by 7, because, that's next to the n. And then we get n is equal to -9/7. All right, and if we were to, and then with these exponents, exponents can be positive or negative. So there's no really extraneous solutions because it says remember to check for extraneous solutions. We're not gonna get that here. Okay, but you can always plug it in and see if it's true. That's how you would know. But yeah, and then here we go. Let's take a look here. Same idea. In this case, it's a lot more simple than number one because we already have bases that are the same. Where's my mouse? There it is. So we already have bases that are all the same. The only thing we need to do is make the, just have one base on the left-hand side. And so let's do that. So again, we're going to go this same base. So that's going to be 3. And since we're multiplying the bases, we're going to add the exponents. So it's 3x plus 2x, that's 5x plus 3 is equal to the right-hand side. Nothing else to do on the right-hand side. Just like that. And then, so now again, we have the bases that are the same. So we're going to set equations or the exponents equal to each other. So that's going to be 5x plus 3 has to equal negative 3x minus 3. That has to be true, because if that's not true, if they're not equal to each other, this whole equation is not true, right? Because if the left-hand side is equal to 1 and the right-hand side is equal to 5, 3 to the 1 power is not equal to 3 to the 5 power. See what I'm saying? Common sense. Right. So then again, we're just going to solve for this. So we're just going to add 3x on both sides. I like getting my x's together first. Right. Get the x's together and then get my constants together. So that'd be 8x plus 3 is equal to that negative 3 right here on the right. And then, oh, that should be a plus. And then subtract 3 on both sides. Please make sure that right-hand side does not say 0 because negative 3 minus 3, not 0, it's negative 6 is equal to 8x. And then you got to get rid of that 8. So we're dividing by 8 since 8 is multiplying with x. And so our final answer is just going to be x is equal to negative 6/8. But we know we can simplify that. If ever you can simplify a fraction, please do it. Okay, and so we know that that's going to be x equal to negative 3/4 because we know that 2 goes into both of them. So negative 6 divided by 2 is negative 3. Negative, or 8 divided by 2 is 4. All right, so there we go. We're going to keep on going here. Oh, yep, I noticed right here, 64 can be written as a base of 4, right? So I'm going to just, I'm going to do 2 things at once, okay? Because I like to condense steps. So I know that they're both 4s on the bottom here, so I'm just going to rewrite this as 4 to the, okay, so I'm going to put I like to have my variables first. So negative 2n plus 9, plus n is going to be negative 1n, or we call it just negative n. And 1 plus 1 is going to be 2 equals to 4 to the what power? And again, if you don't know, use your calculator, okay, whatever calculator you have. And so, oh, I don't have my other online calculator here, but it'll be 4 to the 3rd power. And if you do these often enough, you're just going to know, oh yeah, 4 to the 3rd power is going to be 64. All right, and then from here, again, we have common bases. That means our exponents are going to be the same. So we're just going to set the exponents equal to each other. So negative n is equal, plus 2 is equal to 3. Again, I only have n on one side, so I'm just going to subtract 2 to both sides. And we get negative n is equal to 1. And if negative n is equal to 1, that means positive n is equal to what? Negative 1, right? Or you can just multiply negative 1 on both sides or divide both sides by negative 1. Either way is okay. So, you know, we can just divide both sides by negative 1. 1 divided by negative 1 is negative 1. All right, and there we go. That's the answer. And again, here we're not going to get any extraneous solutions because exponents can be, exponents can be positive, it can be negative, it can be 0, it could be decimals, it can be anything. So we don't really need to check for extraneous solutions here. So here again, 625. There are other ways to solve for these. But I like to just have them be the same exponent. You can change this to a log form and then solve that way if you do not recognize that that is going to be, what is it called? A common base for with 5. That is the other option. Either way you do it, it's fine. It's just two different methods. There's no better way, or well, sometimes some people may argue that there's a better way, but you know, some way may be more efficient. So this is going to be 5 to the 4th power. So 5 to the 4th power is 625. And again, this is just going to be exponents have to be equal since the bases are the same. The bases were different. You couldn't compare the exponents. Doesn't matter. Okay, and then we're just adding 1 on both sides. And then we get 3b is equal to 5, which means b is equal to 5 divided by 3. Right? Because we're going to divide both sides by 3. All right. And if you just skip that stuff because you're like, you know, you can just do it in your head, that's fine. And if you just say b is equal to 5/3, that's okay. Because this is algebra 2. Yes, on the final, I'm going to expect to see some work on there. If you're expecting your grade to be raised, yes, work needs to be shown. I need to know that you know a thing, that you're not just like, oh, spamming guesses. Can't do that. We're not doing that here. All right. Just so that you know you can, well, we'll try it again here. So here we have this little -3 going on here. So I know that 45 is a multiple of 9, but I know it's not going to be like 9 times 9, like 9 times 9 is already 81, like it's not 45, right? So I know I'm not going to be able to get, but maybe 3, right? So +3. But first we need to get the exponent by itself, or the base by itself. So I added 3 to both sides, and then we get 9 to the 3n is equal to 48. All right, and if I think to myself, okay, I can change the 9, because I know this is not a multiple of 9, right? And if you didn't know that, you could always check, 48 divided by 9, what do you get? It's going to be some decimal, right? And then, so I'm going to try 3s, like a base 3, and I go 3 times 3 that's 2 of them, so that's 9. 9 times 3 is 27. 27 times 3, that's 81. So we're not going to be able to do the same basis. Then what do you do? Just like what we said, right? We're going to change this to log form. So if you cannot make them the same base, and even if you can, like for number 4, even if you can, if you'd rather just change it to log form, do it, right? That's totally fine. So again, remember the changing to the log form. So that's gonna be log. Okay, without the log, you can't have log form, right? Make sure you write the log in there. So our base is 9, so that's gonna be our base of what? Of the answer, which is 48, is equal to 3n. So it is equal to the exponent. Okay. So again, once let me just write this out here. You may want to put this on your page of notes. Okay. So here is the base. I'm going to write b for base and e for exponent, and a is the answer. Okay. So this is the exponent form. This is the exponent form. Okay. And this is the log form. So that's going to be log. You can't have the log form without the log. Remember the base is down here. So remember it's a lower, smaller subscript b, okay? And then of the argument, remember we call this the argument, all right? I like to call it the answer. The book likes to call it the argument. I should probably technically call it the argument. Anyways, that's fine. So log base b of the argument, and remember the a is the same size as the log, right? They're not like, it's not like I saw a lot of this. I was like, what is this? Like you're trying to write the a as an exponent. It doesn't work like that. Please don't do that. I'm gonna be so sad. I'm like, do not tell your next teacher that I was your teacher. That's sad days right there. All right. And then so is equal to the exponent, because remember, what are logs? Logs are just exponents. So exponents properties work on logs because logs are just exponents. All right, so here's how the different forms and how they how it would look for those guys who don't remember exactly well. Here's the base. Actually, you know what? We should make the base like brown because it's like at the bottom. Oh, shoot, that's not a good color. Let's make it a little, okay, let's make it orange. Fine. We'll do orange. So here's base right here. So still not that seeable. And then we'll put exponent as blue because it's in the sky. It's powerful. And the answer is right here. Here's the argument. I said answer again. Right, argument is yellow. That's where you see the light. I'm just kidding. I'm just making that up. But anyways, this is the color-wise. That's how that's going to look. All right, back to our old story here. So here we changed it to logs and to log form. And all you're going to do is just divide by 3 here and divide by 3 here. And you get n is equal to. Now, this is what you're going to put in the log. So you're going to remember how to do you're going to be able to use the graphing calculators. And so remember how to do the one where you could do the different bases, right? So you go to math, and then you go up to go down. You'll know what I mean when you actually do that. And then you go to the log base. Yeah. And that's where you're going to find it. And I wish I could show you that here, but I forgot on this computer. I don't have that particular, I didn't download that yet. So sad days. So let me just try that out here. I know I have my different log base. Oh, here you are. So of 948. So again, I would go log base 9 of 48, and then make sure you're outside of the parentheses, or you close the parentheses, and then you go divide by 3. So you see how that goes? Oh, it probably looks backwards to you, but if you can, put the video up to a mirror, you should be able to read that. It's a secret code, guys. Just kidding. Okay, no, I'm not really that kidding, but that's true. All right, so that's going to be 0 point. And so we're going to round to the nearest 10,000th place. 5873. So notice it should be 0.587287, blah, blah, blah. But yeah, it's going to round up to a 3. So there we go. That's what your answer should be. All right, and we're going to do the same thing over here. I see this decimal point, so automatically I know we're not going to be able to do like the stuff we did for 3 and 4. We're going to have to change it to log form. So again, get the exponent by it, or the base by itself. So I'm going to add 5.3 to both sides. So this is going to be 5 to the n minus 8 is equal to 33.3. And then what do we do from there? Change to logs. Then log base 5 of the argument is equal to exponent. All right. And then from here, all you need to do is just add 8 to both sides, because we almost got n by itself, right? And so you're going to get log base 5 of 33.3. So this is going to be in your parentheses, and then you're going to add 8 to it. Okay, notice your 8 is not part of the argument. It's you add 8 after you do this whole log thing. You figure out the number for log, and then you add 8. Okay. So don't get that, because that's a really good way to get the wrong answer. All right, and then let me just try that on my calculator. So it should look something like this. Right, notice that the plus 8 is on the outside of the parentheses. Okay, and then enter, and I get n is equal to 10.1781. So it rounds. It stays at 1 is because the next number is 2. So there we go. That's our answer there. Happy days. All right, keep going. All right, and again, I see decimal points, and so probably we're going to be in log land here. There we go. And so again, we want to get the base by itself. So how do we get rid of this negative 7.5? No, it is not to add 7.5. A lot of people will say that just because they see a negative there, right? But what is the negative 7.5 doing? See that little dot there? That means multiply. So please do the opposite of multiplying, which is dividing by negative 7.5. All right, and then we're going to get, let's see, let's change to this. So 10 to the 10x is equal to, I wonder if it goes in there evenly. So 57.8 divided by 7.5. I don't put in the negatives in there just because I know it's negative divided by negative. It's going to be giving you a positive answer. If you want to put the negatives in there, that's fine. You're still going to get a positive answer, right? And notice it gives me this like long digit thing. So I'm just going to leave it as that weird fraction. Okay, let's pick back colors. So it's going to be 57.8 over 7.5. I'm just going to leave it like that. All right. And then again, we got our base by itself. So it's going to now change to log. So log base 10. Technically, I don't need to write a 10 there, right? Because if the log of just nothing there, we already know it's log of base 10. You want to write it in there? You totally can. Feel free. So base 10 of this argument, so all this guy right here, is equal to the exponent, just 10x. All right. And then from here, what do? Just divide the whole log by 10. All right. And then you're going to get x is equal to, well, we'll find out. So again, we're going to go log. I'm just going to do the regular log. You want to do the one with the base, you can, but you don't need to do that. So 57.8, divide that by 7.5. Make sure you close the parentheses and then go divide by 10. So let's see here. There's the log, right? You should see the log, and then you have the 57, all this stuff. I don't like rounding until the very end because if you round in the middle, you get like less accurate answers, right? You see what I'm saying? And especially if you work in like the engineering field or some place where you have to be very precise, this is how to be more precise. You don't round until the very end. All right, and notice that I have my divide by 10 outside of the parentheses, right? That's what you need to do. Is that 10 is not part of the log. Okay, and so I get the answer of, oh, a small number, 0.0887. So remember, it was 8868, blah, blah, blah. But since, you know, the next number is 5 or greater, so it's going to be 7. It rounds up. There we go. All right, the last one on exponentials. We're almost there, guys. Okay, no, we're not. Actually, it's for exponentials. All right, same idea. Again, got to get rid of this guy. So subtract 7 on both sides. And then we're going to get 13 to the n plus 10 is equal to 49.8, right? Definitely not going to get the same bases here. And so we're, again, going to change them to log. Log base 13 of the argument is equal to n plus 10. All right, and then I'm just going to get rid of this 10 guy. So minus 10 here, minus 10 here. Please, again, I reiterate, do not subtract the argument with the 10. They do not belong together, okay? Do not give me any arguments about that. Also, I'm sorry. So, so we're going to have here log base 13 of 49.8. I'm just going to put that in parentheses so I know that this is not part, or the 10 is not part of the argument. Minus 10 is equal to n. All right. And then again, oops, not that guy. Actually, I can put it in here. I do have a calculator on here. So I'm going to do the log. I'm going to go math. And then it's going to be base 13 going over to 49.8 without the parentheses minus 10. All right. So it should look, oh, can you see that? I don't think so. Is that an angle? Oh, wow. That's pretty bad. Let me see if I can make it a little brighter. Can you see that? Ooh, I don't know. I don't think you can see that. Sad days. Maybe I'll stick with my other calculator. But anyways, the 10 was definitely outside of the parentheses. And I got the answer of n is equal to negative 8.4763. Oh, just kidding. Not 63. 64. The next number is a 7. Okay. There we go. And again, we do not have to check for extraneous answers or solutions because exponents can be, there are no restrictions for exponents. Right now, onto logs. Bum, bum, bum. All right, so there are a couple of different instances here. If you notice for 9 through 12, they both have logs on both sides. When you have logs on both sides, you want to condense each side so each side only has one log, which all of these have. So we're good. We don't even have to use any properties because they're just logs on both sides. So if there are logs on both sides, that's like the easiest scenario. You're like, this is like cake, right? Then that just means that this argument here has to equal this argument here, right? The log of whatever number this is better be equal to the log of whatever this is. This number, like the two highlighted numbers, have to be the same, right? So what do? Set them equal to each other because we know that has to be the same. Logically, that's what we're doing. Some people like to think, oh, you just drop the logs, but that's a dangerous way to live. Okay. I am going to add 3b on both sides just because I don't want to deal with the negatives. I mean, I don't mind negatives. It's just one more thing for me to write, so I'd rather not, you know. So here we go. So we get -5 is equal to 7b plus 9. All right, and now I'm going to get rid of the 9 because 9's got to go over on the other side. So -9 on both sides. And then you get -14 is equal to 7b. Ooh, what's it going to be? B is equal to -2, right? If you're going to divide both sides by 7, -14 divided by 7 is -2. Right, this one you do need to check because the arguments do have a, what is it called? They do have a restriction. So these ones, the arguments cannot be, so I'm going to just write it right here. Arguments cannot be 0. Oh, that's a terrible 0. 0 or negative. You cannot have that. Okay, and the reason why you can't have that is basically, okay, again, like I've said it at school, come on, dudes. You know what, I'm sticking with blue. All right, so it cannot be like, okay, so here's log, let's see what happens, like base 2 of -4, let's just say, is equal to x. So we can say 2 to the x, so we're going to just change the exponents, right? So 2 to the x power is equal to -4, right? If we were to change the exponential form. And look at this, right? So 2 to what power? So basically, how many times do we need to multiply 2 by itself to get a negative number, right? 2 times 2 is a positive number, times 2, still a positive number. How are we going to get a negative number? You can't unless one of those 2's is negative, but we can't because we're never going to do that. You see what I'm saying? It's not possible. So we can't have it be a negative number. Then you're like, well, what about 0? We still can't change this. Okay, it's being silly. So I'm just going to pretend. Here's the 0 right here, right? So then how many, again, same thing. Right? How many times can you multiply 2 to get a 0? You can't do that, right? It's not possible because one of those numbers has to be 0 if you're multiplying, right? And you're never going to do that because you're always going to be multiplying by 2. See what I'm saying? So it's not possible. So that's why the arguments cannot equal a 0 or a negative. So we're just going to check that just in case. So negative 4 times -2, I always like to do this in my brain, is -8, and -8 plus 9 is 1, okay, which is definitely greater than 0, so we're good with that. And -2 in here, -2 times -3 is +6. I'm going to say right here, -3 times -2 minus 5. So this is going to be 6 minus 5, which again is 1. So, you know, if I'm like doing the work backwards up, going up this way, so I can't go down. See what I'm saying? So it is going to be positive, so we're good. So we know that b to the -1 is correct. Let's go a little faster. Please, again, stop at any time to do your, I really don't know what's going on with this computer. All right. So again, arguments are exactly this, the logs are exactly the same basis, which means the arguments are equal to each other, or they better be, or it's not going to work out here. It's going to be sad days. All right, get the p's together. So I'm going to add 2p to both sides. And this time I'm going to get rid of this -2p on the right because it's negative, and so I just want to add, right? And so that cancels out, and look at that save. So 5p plus 4 is equal to -1, right? And again, subtract 4 on both sides, and we get 5p is equal to -5, which means p is equal to -1. How do we get -1? Remember, you divide both sides by 5, and then you get -5 divided by 5, -1. Try it out for yourself. All right. Then let's just check that out. Negative times negative, that's going to be a +2. And 2 minus 1 is going to be a 1. And 3 times -1 is -3 plus 4, which is again going to be 1. So we're good to go. Right here, number 11, we got log again. So this guy right here is going to equal this guy right here. So -5x is equal to -2x, right? I'm going to again get the x's on both sides. So I'm going to just add 5x to both sides. That just becomes 0 is equal to 3x. So what does x have to be? 0, right? Because 3 times what number is going to give you 0? Only number there is just 0, right? If you want to divide both sides by 3, right? Same thing. 0 divided by 3, again, is still 0, right? And if we plug this back in, what is -2 times 0? 0. See, this is where the problem is, right? Remember, we said this before. Arguments cannot be 0 or negative. And if we plug in a 0 in here, it's going to make that argument a 0, which means it's an extraneous solution. It doesn't work. So we're just going to say no, there is no answer. There is no possible number for x where this will be true, where both the left and the right-hand side will equal each other. It's not possible. So no solution. See, that's why you check. Again, right here, this one is pretty simple. Again, arguments are equal to each other. Ooh, that's an M. Oh, my dear. Is equal to 24. Again, you're going to just divide by -3. You get M is equal to -8. And if I plug in -8 in here, is -3 times -8, which is +24, which is fine. Happy days. Okay, now, if you have, now see, this is a little different because we have logs on the left-hand side, but not on the right-hand side. The right-hand side is just 1, in which case we need to change our strategy, all right? And some of you guys may be thinking, well, what if I just add this log over to the right-hand side? I mean, you can, but then you'll still have this like random 1 over here on that's not a part of any log, right? So you can't, that's not a good strategy. So what we're going to do is we're going to use the log properties. So since this is, we're going to just combine, remember just how we combined the bases for the exponential one, we can combine logs, right? And so instead of having 2 logs, we're going to just combine into 1 log. So there's log base 7. And then we have, since we are subtracting the logs, when we combine these, we're actually going to be dividing. So that's what that's going to look like. 1 second. All right, and then when you have, when you combine them together, then you're going to change it to exponential form, right? We cannot, you know, just drop this 1 log, right? There's no other log, right, on the other side. So 7, so it's the base to the 1 power is equal to 3x over 9, right? And then 7 to the 1 power is just 7. And then you're just going to get, I like to just simplify this. So this is 3 over 9, which is the same thing as just 1/3, or just x over 3, right? Remember, there's that little 1, the invisible 1, right? Not imaginary 1, invisible 1, right? You just can't see it. And then from here, we're just going to multiply both sides by 3 to solve for x, and you get x is equal to 21. Sorry, that looks like a really weird 21. Right? Oh, I should check this. 21 goes into, yeah, and it doesn't make the log negative, so, or 0. So we're good to go. All right, and then same thing with this one right here. It is a minus, so we are going to combine them. So it's a common log, so it's automatically base 10. So it's going to be 5x squared divided by 8 is equal to 3. So remember when we have that divide, we mean, when we have this minus, it means when we combine them together, we're dividing. All right, so again, we're changing to log to exponents. So base 10 of 3 is equal to 5x squared over 8, right? And then 10 to the third power is just 1,000. You always use your calculator for that if you did not know that. And then 5x squared over 8. And here, okay, my colors work now, yay. So we're going to multiply both sides by 8 to get rid of the 8, right? And how to get rid of the 5? Just divide both sides by 5, right? So this is doing like 2 steps in one. If you want to break it down into 2 steps, go for it. You can multiply by 8 first, figure that out, and then divide by 5. It's the same thing. So here, the 8s and the 5s are going to cancel out, and all you have left is 8,000. So 8 times 1,000 is 8,000. Divide that by 5 is going to be, we'll figure that out, 8,000. I could do it in my brain, but I can't do it right now. So 1,600. So we get 1,600 over here is equal to x squared, right? Again, I got the 1,600 by multiplying 8 times 1,000 and then divide that by 5. Please try that for yourself so that you know how to do it on the calculator. And then here we got to get rid of the square. You square root it, right? So you square root both sides, and the square root of 1,600 is going to be 40. So remember, when we're square rooting both sides, it's plus or minus, because it could be both positive and negative. And if we were to check this back in here, the only x that you see is right here, and you know that this x is always going to be squared, so it can be both positive and negative 40. If, like, let's say there was an x over here, then we would not be able to use a -1 just because it would make that argument negative. But yes, we could use both. Moving on to number 15. Again, please feel free to skip forward or backwards or all the things that you need. Okay, so I just did all of them be divide, huh? Just know that if this was a plus, you would just be multiplying them. My bad. So log base 2, and again, x minus 6 divided by 6 is equal to 2. And we're just going to change that to exponential. So 2 to the 2 power is equal to x minus 6 over 6. This does not cancel out, right? Because 6 divided by 6 is 1, right? And then we still would have to multiply the x, or divide the x with 6. So you just can't cancel those out. Again, we're just going to simplify that. X minus 6 divided by 6. So first thing we're going to do is we're going to multiply both sides by 6. And what do we get? We get 24 is equal to x minus 6. Then we're going to add 6 to both sides. And we get x is equal to 30. And if we put 30 back in there, 30 minus 6 is 24. We're good. We're fine. That does not make it a negative number. All right. Again, I'm just going to combine these guys. Again, this is a minus, so we're just going to go x divided by x minus 2 is equal to 2. Change that to exponential form. 3 to the 2 power is equal to x over x minus 2. I'm just going to rewrite this as a 9. Now, how do you get rid of this x minus 2 on the bottom? The same way you would get rid of anything that was on the bottom, right? You just multiply both sides by x minus 2 times by x minus 2. I mean, that could be parentheses. So that this is going to cancel out, and what do we have left? It's going to be 9 times x, which is 9x, minus 9 times 2, which is 18, is equal to x. And then we just, how we normally do. Write 9x on both sides. The reason why I'm doing that, because we have this minus 18. This is out, and we just get negative 18 is equal to negative 8x. Divide both sides by negative 8. And we get x is equal to 18 divided by 8. I'll leave that as a fraction, but I wanted to simplify it since 2 goes in both of them. 9 over 4. So 9 fourths. If I plug that 9/4 back in, that's going to be fine. It's just because 9/4 is a positive number. 9/4 minus 2 is going to be, because 9/4 is just 2.25, which is definitely bigger than 2. So you're not going to get a negative number there. So we're good to go. All right. And now we're on to quadratics. Get ready, get ready. Make sure that, so this is the form that we always wanted in. We want one side to equal 0, whether the 0 is on the left side or right side, we don't care. As long as one of the sides is equal to 0 and everything is on the other side, we're good to go. And again, there are technically there are 3 ways, but 2 ways that we're going to use. So the first way is just by factoring. That's like the easiest way, the way to make the least amount of mistakes. If we can't do that, then we're going to do quadratic formula. Technically, the third way, do you remember the third way? Completing the square. Not a lot of people use that one though, because it just gets like tricky fast. So we're going to use one of those 2. All right. So here I'm going to just, again, we use the crisscross method to see 2 numbers that multiply to 40 and add up to 13, or technically negative 13. And so I'm going to be like, not 2 and 20, because that would not, 1 and 4, 10 and 4, no. So not 2 and 20, 2 and 20, 10 and 4, 1, 2, 3, 4. I'm going to go through 5 and 8. There we go. 5 and 8. When we add those up, that will be 13. So that's good to go. So I'm going to be -5 and -8. The reason why is because when we add them together, that will give us that -13. All right. And so once we do that, we're going to, because I've already checked it in my brain, right? Because my coefficient is just 1 here. So it's just going to be x minus 5 times x minus 8. All right. And when we add these guys up, we know that that's going to equal up to -13 right there. So that's going to be our factored form. And then remember the zero product property, which means that if the answer is equal to 0, both of these or one of these has to equal 0. So we're just going to set both of them equal to 0 and see what our possible answers could be. So x minus 8 is equal to 0. And then here we can just do this in our head. That's got to be 5. It's 5 minus 5 is 0. And 8 minus 8 is 0, right? That's a comma, not a decimal point. The answer is 5 and 8. All right, and then same thing with this one. We've got k times k. And here, 2 numbers that multiply to 8 and add up to 6. So that would be 4 and 2, right? Because 4 times 2 is 8. 4 plus 2 is 6. We have no negatives in here, so we're good to go. This is just going to be k plus 4. And then k plus 2 is equal to 0. So again, setting these equations up. So k is equal to -4 and -2. Order does not matter because we're just listing out the solutions. That's it. All right. Here, and again, here we do not have to check for extreme solutions because there's no restrictions on these things. All right. And again, here we got n times n is equal to n squared. And we know 5 and 1. 5 times 1 is 5, but one of these have to be a negative because when we multiply, it has to be a -5. And that's going to have to be the -5 here because that's going to have to add up to -4. Again, here's the cross multiply part, that n times the crisscross part, n times n negative n, or n times -5, which is -5n, and 1 times n, which is just 1n. And when we add them up together, that's going to give us that -4n, which is that middle term right there. I've been just skipping this part right here because I don't have any coefficients that I need to check. All right, so here we got n minus 5 times n plus 1. Honestly, if you said n plus 1 times n minus 5, that's fine. It's just multiplying. Order does not matter when you're multiplying. And then again, setting these up. See, again, this is a lot shorter process than our quadratic formula. You know what I mean? So n is equal to 5 and -1. So here we got b and b, and then -40 multiplies to -40. So like 8 and 5, and that has to add up to a -3. So that a negative has to go with the -8. And so it's going to be b minus 8 times b plus 5 is equal to 0. So guys, when you guys go to the next level of math, knowing how to factor is going to be really useful. Again, 8 minus b is equal to 0. B plus 5 is equal to 0. So b has to equal 8 or negative 5. Ooh, now we're getting a little trickier. You see how it's not equal to 0? It needs to equal to 0, so we need to add 2 to both sides. So get everything to one of the sides. It doesn't matter which side, just one of the sides. So then we're going to get 7b squared minus 35b plus 28 is equal to 0. You see here, we have a coefficient here other than 1. So I'm gonna really like focus on this crisscross method here. So I know one of them has to be a 7v and the other one's gonna be a v. Now, two things that multiply to a 28 does not necessarily have to add up to 35 because we're gonna multiply one of the numbers by 7. So I'm gonna be like, well, 7 and 4 first come into mind. So I'm gonna put the 7 on top and 4 on the bottom. And if I multiply, 7 times 4 is gonna be 28. V times 7 is going to be 7v. I know I wanted to add up to negative 35, so that means both of these guys have to be negative. So then when I add them up, that's going to be negative 35v. Ooh, happy days. So make sure to put the negatives there so that we're good to go. This is, again, when I really like lean on this part right here just to confirm, because that 7 does, weird things. Now, again, we're going to go straight across. So we're going to go straight this way. And this way. So we're going to write 7v minus 7 times v minus 4 equals 0. All right. Setting these equal to, again, let me just show you. So that's this yellow, and goes with the yellow. Oh, where's my mouse? There it is. Blue goes with the blue. So this is going to be 7v minus 7 is equal to 0, and v minus 4 is equal to 0. Do a little bit of algebra here. We get 7v is equal to 7, which means v is equal to 1. All right, and then so we got v is equal to 1, and this is going to be just positive 4. All right. Excuse me. So we're just going to do the same thing here. So I'm going to add 2 to both sides, and I notice right here, 3p squared plus 24p is equal to 0. Now notice I have no more constant, right? So what I like to do is I just like to factor out the GCF. Okay? That just makes life a little bit easier. This is the other way to factor since we don't have a c here. Like this, the third constant. So I know I can take out a 3 from both of them, as well as a p. So that's my GCF, my greatest common factor. So what do I have left is just a p. How do I know that? Because 3p times p is 3p squared, right? We're doing we're undoing like the distributive property, basically, right? We're undoing that. And so we know 3p times 8 would be 24p, right? And so that's equal to 0. Again, now it's factored, and we're going to set each side equal to 0, or each term equal to 0. And again, this is just going to be 0 and negative 8, right? Because 3 times 0 is 0. All right, moving on, trying to go as quick as I can, but still explaining. And not equal to 0, so we're just going to add 4 to both sides. We've got p squared minus 11p plus 28 is equal to 0. The reason why we wanted to equal 0 is because we want to be able to use the zero product property, right? You can't do the zero product property without the 0, right? Then you would just have product property. There's no such thing. All right, so let's factor again. So p times p, and we got 7 and 4, and we know that 7 times 4 is 28. But remember, it has to add up to a negative 11, which means both of these guys have to be 11. Mean negative, right? Because negative 7 times negative 4, or plus negative 4 is negative 11, and negative 7 times negative 4 is positive 28. You get p minus 7, p minus 4 equals 0. So again, set up the equations. We know that P is equal to 7 and 4. Ba-bam. All right, and let's keep on going. I'm still using P. I shouldn't use P. All right, A squared plus 60A plus 224 is equal to 0. I notice here that everything can be divisible by 4. And if you notice that, so technically, if you look up here, everything was divisible by 7. So if we had divided everything by 7 first, that would have saved us a lot of trouble. But that's okay. But you see here, it didn't matter, right? But so let me just show you. So so if you notice that, great, right? That'll save you a lot of time. But if you don't notice that, that's fine, because as you can see over here, we can still manage, right? But if you notice like these big numbers, I would definitely look for multiples, right? Since they're all divisible by 4, we're going to just divide all this by 4, divide the right-hand side by 4, because you can't just do it to one side, you got to do it to the other side. But the cool thing about 0 is that it'll absorb that, like it doesn't care, right? The 0 divided by 4, what is it? Just 0. So that's the good thing about 0. So 4 divided by 4 is just going to leave us as a squared. 60 divided by 4, so plus, and that's going to be 15. 15a plus 4 divided by, or 224 divided by 4, that's going to be 56. There we go. All right, and then from here, you're just going to do now, see how it's smaller? Much better. So a times a, and that's going to be 8 and 7. 8 times 7 is 56. 8 plus 7 is 15. You do not know your multiplication tables very well, it's just a good reason to start, right? It's never too late. You can always start learning your multiplication tables like really easily, and you'll find that math is a lot more pleasant that way. Yeah, and learning to work with negatives. But you know, a plus 7 makes it easier. Just because you don't know it doesn't mean it's impossible to do it. You can still do it. You can still do this stuff. A plus 8 is equal to 0. And a plus 7 is equal to 0. So you get a is equal to negative 8, negative 7. Those are our two numbers there. All right, we are like more than halfway right there. So again, if you're like, okay, I think I'm getting this, try this yourself. Okay, you really need to do that. Pause, just do it yourself. Don't just listen to me and just copy things down brainlessly. That does nothing for you, or very little. I won't say it does nothing. It's better than not doing it at all, but you know, you're going to look at it again and like, what was it again? I don't remember, because you didn't give your brain a chance, right? Again, this is not equal to 0, so we got to move everything to one side. And so 5x squared, you're not adding these guys together because this 13 does not have an x. So they don't mix like that. So here you go. Oh, sorry. So there's minus 10x, and then minus 13 is equal to 0. Right, and again, now we cannot factor anything out because 13 is not divisible by 5. So we're going to have to just do this the hard way. It's not that hard. The crisscross method. So one of them has to be 5x, and the other one is just x. Here, the only way to get 13 is, we can't, is to get 13 and 1. But if I go 13 and 1, 5x times 1 is 5x, and x times 13 is 13x. But there's no way I'm going to get a 10 with that, right? And if I were to switch these two and have the 13 be on the bottom, then I would have to multiply, you see, like the 5 with the 13. Can't do that. Then what do we do when we can't factor it? This is where we do the quadratic formula, so make sure you write this down. So here's the quadratic formula. Remember the song? I ain't going to sing it for you. So here's a quadratic formula. So remember, x equals negative b plus or minus square root b squared minus 4ac all over 2a. Oh man, I always want to say that. But okay, here we go. So that's the quadratic formula. And you're like, wait, what was the a, b's, and c's again? You don't know your a, b's, and c's? Not these guys. Just kidding. So here again, that's your a, there's your b, and there's your c. Okay, and so our a is we'll represent that as a is 5. Okay, so all these a's right here, that's going to turn into 5. And our b's, let's make them orange, and that's going to be our -10. So don't forget that minus there. So all our b's are negative. So this guy right here, notice I did not include that square because that square is not the b. Notice I did not include the negative because the negative is not a b, right? So there we go. And then we got our c. We'll make the c. Okay, it's glitching out. Okay, there you go. Oh, I'm doing it again. We'll make that blue, and let's get -13. So that's going to be right here. C is only in one place. So here we go. So x equals negative, and then b. So I'm going to put in -10 plus or minus square root b squared. So it's going to be parentheses 10 squared. Don't forget your parentheses. Minus 4. It's always going to be 4 times a, which is 5, times c, which is -13. Just going to stem that all over 2 times 5. Right? So now we're just going to simplify all this. So x is equal to negative of a -10 is +10, plus or minus the square root. I like to use the calculator on the inside here. We call the inside the discriminant. And so that's, well, this is going to be 100. Okay, now it's going to get a little more complicated. So let me see. It's going to be 100 minus, so technically that's a negative and that's a negative. So that's going to be a plus. That's going to be 360. So that's going to be the square root of 360. Divide that by 10. All right. And then I'm just going to, okay, do you guys remember how to simplify 360? Go 360 in here. I know that I can pull out a 36 and a 10. I know that 36 is a double, 6 and 6, right? I'm going to just stop right there. So that's my double that can pull. That's my perfect square that I can pull out, right? So this is just going to be equal to the 6 root 10. And I know that 10 does not have any perfect squares in it because the factors are just 2 and 5, right? There's nothing common, right? So this can be 6 root 10. So I'm going to rewrite this as 10 plus or minus 6 root 10 over 10. I'm going to just simplify that again. So I know that all three of those terms are divisible by 2. So that's going to be 10 divided by 2 is 5, plus or minus 6 divided by 2 is 3, root 10. Leave the root 10 alone, because the 3 and the root 10 are connected together. So we just need to divide one of them. And technically we can't divide this root 10 by 3 or by 2 because it's in the radical. And then that's going to be 5 on the bottom. All right. So there's your answer right there. Okay, that's 2 answers because one of them is going to be the plus, and one of them is going to be the minus. All right. That was a lot, right? So let's keep going. If you need a break, go for it. I'm going to keep on going. So again, we need one side to be 0. 5x squared minus 7x minus 12 is equal to 0. Again, you can just assume all of these are not factorable. I'm going to just say that right now because that's this area right here. And so again, x is equal to negative b. So negative of -7 plus or minus square root b squared. So -7 squared minus 4 times a, which is 5, times c, which is -12, all over 2 times a, which is 5. So again, you can use the quadratic formula for any kind of problem, that's quadratic, right? Like even for the factoring ones, you can still use it, right? But it is a much nicer process if you can just factor it, right? It goes a lot faster. And here there are so much room for mistakes, right? And like if you miss a negative or you forget to add, and all the little things, right? But if you can only learn one thing, then I guess the go-to is the quadratic formula. But I would recommend learning both. It would make your math experience a lot easier, especially next year. So let's figure out what's that inside. If I get 289, And I am going to, I was like 289, that seems so familiar. So I square rooted it and we actually do get a number, 17, which means that this was factorable. Well, but see, do you see how I could, the reason why I can tell is because I get a nice number like that. So this is equal to 7 plus or minus 17 because the square root of 289 is 17 divided by 10. So now you can't just leave it like this because, like this one, we don't know what the square root of 10 is. So we're just leaving it like, well, this is the exact answer, right? We don't want any rounding. But here, like we could actually do more things. So again, we're going to go the first answer because I told you, remember, the plus or minus, that's two answers. So 7 plus 17 is going to be 24 divided by 10. And then the 7 minus 17, which is going to be negative 10 over 10. I'm just going to simplify those down and I'm going to get, let's see here, 2 goes into both of them, so 12 divided by 5. And this is going to just be negative 1. There you go. Yep, when you get numbers like that, you know that it was factorable. If you get numbers like this with the radical in it, not factorable. Okay, we have 2 more problems, 4 quadratics. Then we're going to go into radicals. Happy days. So here we go. So I'm just going to move everything to the left here just because I want to keep my a positive. I just like keeping my a positive. So 6n squared, this is going to be plus 10n. This is going to be minus 56 is equal to 0. I just did that all in my head. Okay, and if you want to do it that way, feel free to do it that way. That's fine. I noticed that everything is multiplied. I can divide by 2 for everything. So I'm just going to divide both things by 2. This is a step that's optional. You don't need to do it. I just like to work with smaller numbers. I don't like dealing with these big numbers. I'll take any chance I can to simplify them or just make it a little bit smaller. So that's going to be 3n squared. This is going to be plus 5n, and this is going to be 28. And is equal to still 0. All right. Let's see. I don't think it's factorable. Maybe it is, but since we have the quadratic formula, I'm going to just show you a couple more times how to do that. So x equals negative of b, which is 5, plus or minus the square root, b squared, so 5 squared, minus 4 times a, which is 3, times c, which is negative 28, all over 2a, 2 times 3. So that's going to equal negative 5 plus or minus square root, all that guy. So it's going to be 361 all over 6. I'm just going to check to see what that square root is. Oh, it's 19. So yes, it was factorable. I was thinking it might be factorable, but wanted to show you the other way of, just the quadratic formula way, because I didn't do that much. 19 all over 6. And again, negative 5 plus 19, which is going to be 14 over 6. And negative 5 minus 19, which is going to be negative 24 over 6. So here I'm going to simplify, so it's going to be x is equal to, and that's going to be 7 divided by 3. So 7 over 3, because both of them are divisible by 2. And this is just going to be negative 4. All right, last one of these. So 2m squared here plus 12m minus 80 is equal to 0. Again, I'm just adding 12m on both sides, then subtracting 80 on both sides. I'm just doing that in my brain. All right, and again, I notice that all of these are divisible by 2. Again, this is an optional step. I just, again, like to work with smaller numbers. It just makes my life easier. I don't have to deal with really, really big numbers. And then this is just going to be m squared plus 6m minus 40. So here I notice I have a coefficient of 1. I'm just thinking, can I factor this? 8 times 5, 4 times 10. Ooh, I can do 4 times 10. Now it's factorable. Okay, but I said I would show you with quadratic formula. So inside this radical, we will get it'll be a perfect square. So again, did you guys notice what I was doing here? That should not be an x, that should be an n. This one, is that supposed to be an x? But that's an X and that's okay. Shoot. I was like, that's not even an X. There's no X. So hopefully that did not confuse you. I'm sorry. All right, so M is equal to negative B, so negative 6 plus or minus the square root B squared, so 6 squared minus 4 times A, which again here is that invisible one, times C, which is our negative 40, all over 2 times A. M equals negative 6 plus or minus. That's going to be 36 plus 40, 160. That's going to be 196. Yep, like I said. Square root of 196 over 2, which is going to be negative 6 plus or minus, oh, what was it, 16? What it is. I forgot. Oh, 14. You're right, 14. So this can be 14 over 2. And so this can be negative 6 plus 14, which is going to be 8 over 2. And negative 6 minus 14, which is going to be negative 20 over 2. And ultimately, that's going to be M is equal to 8 divided by 2, which is 4. And negative 20 divided by 2, which is negative 10. Boom. And remember, I said it was 4 and 10. You know what I mean? But do you see how much more work we would have to do just to get these numbers when we could have just factored and been way easier? But anyways, I digress. All right, we are almost there because there are 40 problems here and we're on problem number 29. So let's get it together. So here is our radicals. I know that because I have a radical, a square root right here. I just have the radical. The goal is to get the radical by itself, which it is. There's nothing outside of the radical on the right-hand side of the equation. So then what I do, how to get rid of the radical? Square both sides. I'm going to just take this, I'm going to square it, right? And then what do we get? 25 is equal to, remember the square root and the square cancel out. So all I have is 1 minus 24. Okay. And now it's just an algebra 1 problem, right? A two-step problem. So again, we're going to just subtract 1. 24 is equal to negative 24k. And divide by negative 24. And we get k is equal to negative 1. We do have some restrictions in here because inside the radical, we cannot have negative numbers. We could have 0. We can't have negative numbers. So we just need to make sure we check that. So negative 1 times 24, negative 24, that's going to be positive 24. So that's going to keep that positive. So we're good to go. I just do a visual check. I don't like actually write it down. Sometimes I do if it's a little bit more complex, but this is just a negative 1. So that's fine. Here again, the outside, there's nothing out here. So I'm just going to just square both sides. So we get 49 is equal to 1 minus 8n. Right? The reason why we square both sides is to get rid of the square root. So you should no longer see the square root there, right? Or else we didn't do what we're supposed to do. And again, subtract 1 on both sides. We get 48 is equal to negative 8n. That is an 8. Divide by negative 8. And we get n is equal to negative 6. All right, and again, plugging that back in, negative 6 times negative 8 is positive, so we're good to go. Okay, now see, do you see here, this is a something on the outside. Radical is not by itself, so we're gonna have to get rid of that first. So we're gonna just divide both sides by 9, right? Because 9 is multiplying with the radical. And then we're going to just get the square root of 17x minus 4 is equal to 8. And we know that, yeah, now we have just the radical by itself. So we're going to, again, square both sides to get rid of the radical. And we got 17x minus 4 is equal to 64. And then again, two-step problem, plus 4 on both sides. 17x is equal to 68. Divide by 17 on both sides. I don't know my 17s that well, but I'm going to say that's going to be about a 3, 4. About a 3, 4. Yeah, or 4. Right. Probably just in case. 16 divided by 17. Yep, 4. Okay, and if I multiply that in there, 4 times 17 is definitely going to be bigger than 4, so we're not going to go negative. So it's good to go. Again, notice this plus 8 is not inside the radical. We got to get rid of it first. Then we can start squaring. So negative 4 minus 2n is equal to 2. And again, we're going to square both sides. And we're going to get, let's keep it blue, negative 4 minus 2n is equal to 4. And then we're going to add 4 to both sides. Negative 2n is equal to 8. And then divide by negative 2. And 8 is, or n is equal to, I'm just going to write it here, n is equal to negative 4. If I plug that back in here, negative 4 times negative 2 is positive 8, which is going to be bigger than this negative number. So we're good. All right. Now we have rationals. This is the last type of equation, because if you notice on the bottom here, we have some more radicals for some strange reason. Well, probably because we have like 2 radical problems on them. Let's see. Okay, so then from here, notice I do not have common denominators. I need to have common denominators. So what am I missing here? So this 3 is missing an n, right? So I'm going to multiply, let me make this, I'm going to multiply this fraction by 1, a special type of 1, right? So this is going to be n, or n divided by n, right? If I'm just multiplying something by 1, I'm not changing the value, right? I'm just changing the way it looks. It's just like makeup, right? Not changing who you are, just what you look like, right? It's the same person, hopefully, right? So here we go. So we're just, so now we have the denominator of 3n. And then same thing here on this one, right? The second fraction that we have, this one is missing a 3, right? It has the n, it just doesn't have the 3. So I'm going to multiply the top and the bottom by 3. So that's just 3 over 3, which again is 1. So same thing with this one right here. So we're going to multiply this one by 3 as well. So now we're going to rewrite everything. So n times 1 is just n over 3n. Right? Plus 3 times 3, which is 9, over 3 times n, which is 3n, is equal to, I'm going to just distribute this guy. So 3 times n is 3n, plus 3 times 4, which is 12, over what? 3 times n, 3n. Notice they all have the common denominator, right? So I'm going to write the left-hand side as one denominator, one fraction, I should say. So since it's common denominators, we just, add them up. So n plus 9 over 3n is equal to 3n plus 12 over 3n. Now again, okay, remember like the exponents, like if the bases were the same, then the exponents are going to have to equal each other. So again, same idea here. If the denominators are the same, that means the numerators on the top, the guys on the top, have to be equal to each other, right? Same denominator, it's the same numerator, right? So if you know that these two are the same on the bottom, that means this right here, well, let's do it. Has to equal this guy right there. They have to be the same. So let's do that. So we know that 9 plus n has to equal 3n plus 12. Let's do it. Because, we've been doing this before, right? So we're going to, again, minus n on both sides. I like to get the numbers of the variables together first. And then we're going to go, 9 is equal to 2n plus 12. And then we're going to subtract 12 on both sides. We're just going to move this up here. So we're going to get, that's going to be negative 3 is equal to 2n. And then divide both sides by 2. We get n is equal to negative 3 over 2. You could say negative 1.5, but I like to keep mine as a fraction. So some of you guys may wonder, well, how do you know the denominator was 3n, right? Since n and 3 are both different, that means we have to have both of the things on the bottom, right? Yeah. So if you see right here, we have 4, so we know that 4 has to be in the denominator. We also have the max number of b's we have is a b squared, right? Which means that we know that these both have to be b squares as well. All right, that's how you find common denominators with variables in them. All right, so this one has a 4 and a b. So it doesn't have another b, right? So let's multiply this by b over b. This one has everything that we need, 4 and a b squared. So we're good. And then this one, it only has a b, so we need a 4 as well as a b. So we're going to just multiply the top and bottom by 4b. Okay. And then our denominator, okay, so now let's multiply this out. So we're going to get b times 1, which is just b, over b times 4b, which is 4b squared, equals, this one stays the same, because we already have, the denominator is the common denominator, minus 4 times, well, the top part is just going to be 4b over 4b squared. And again, I just want one fraction on each side. So we get b over 4b squared is equal to 1 minus 4b over 4b squared. Okay, again, same denominators means our numerators have to be the same. So b is equal to 1 minus 4b. I'm going to get my b's together. So add 4b to both sides. And we're going to get 5b is equal to 1. And what do we do from there? Divide by 5, divide by 5. Do not say that b is equal to 5. It doesn't work like that. So b is equal to 1/5. That's good. 1/5. Happy days. All right, with these kind of fractions, we don't have any restrictions. We're not multiplying or dividing anything like together. So we're fine. Oh, actually, you're right. We cannot divide by 0. So the only thing we need to make sure is that this denominator number would never equal 0. And if this is 1/5, we're fine. Okay. Usually you would see an issue with that if, or I should say, never mind. I should not compare that to another problem. I should compare it to the ones up here. But since we're not adding or subtracting, as long as b is not 0, we're good. And b is not 0, it's 1/5, so we're fine. All right, same thing here. Common denominator. Well, nothing else has a 3, but we have this 1 3 here. And our biggest variable is just r squared. So everything has an r squared, so we're good with that part. We just need to multiply by 3 for both of these two fractions right here. All right, and so we end up getting 3 is equal to, 3 over 3r squared is equal to 18 over 3r squared minus r plus 3 over 3r squared. Okay, so then from here, it's a little bit tricky part, but you're fine. Okay, again, we want to write the same fraction on the top and the bottom, or on both sides of the equation. So this is going to be 18 minus all of that. You see where I put parentheses right there? I did that on purpose because you need to. Because remember that minus is for both the r and the 3, not just the r. Right? And if you didn't have the parentheses there, you wouldn't know that. All right, so I'm going to just rewrite this. So I'm going to get 3 is equal to 18. I'm just going to distribute that minus. So it's going to be minus r minus 3. And I'm going to just combine those on that side. So 3 is equal to 15 minus r. 18 minus 3 is 15. So 15 on both sides. So we just get negative 12 is equal to negative r. If negative 12 is equal to negative r, that means r is equal to 12. And if you wanted to multiply both sides by -1, that's how you make, algebraically, that's how you make it positive. All right. And our last rational one, again, all of these have a k squared. We just need a 2. So we're going to multiply this left-hand side by 2 over 2, and the right-hand side by 2 over 2. So we're just going to distribute that out. So we get 4k minus, I see what I did. I didn't multiply that out. So 2 times 6, which is 12, over 2k squared. Plus, this already has our common denominator. So it's just, I'm just going to copy it down. Is equal to 2 over 2k squared. And now we're just going to write it as one fraction on the left-hand side. All right. I'm going to combine like terms over here. So I'm just going to 4k minus 11 is equal to 2. So 4k is equal to 13, which means that k is equal to 13 over 4, or divide both sides by 4. Okie dokes. Last 4 problems. We've done these before. So remember, please pause and try it yourself. Oh, I can't do it again. Oh well. We ended up on a good color. So my radical is by itself. I'm going to square both of these guys. I get 81 is equal to x minus 9. Add 9 to both sides. And that's going to be 90. See how easy that is? 90 does, when I plug it back in, 90 minus 9, 81. Square root of 81 is 9. Again, right here, got to get rid of this plus the minus 8. Right, because we want to get the radical by itself. And that's going to give us, not negative, that'll give us 6. And then again, oh, you know what? I'll do that. That's fine. Again, we're going to just square both sides. We got v plus 2 is equal to 36 minus 2, and we get v is equal to 34. Happy days. 34 plus 2, we're good to go. That's definitely positive. Our last 2, yeah, please do not add 7 on both sides. A lot of people do that. That's multiplying. So the square root of negative 8 minus 8b is equal to positive 8. A lot of 8's going on here. We're going to square both sides. And negative 8 minus 8b is equal to 64 plus 8. And we're going to get negative 8v is equal to 72, and which means v is equal to negative 9. All right. And last one. And oh, again, please check the answers in the back. I remember there's all these answers right here. Right. I may have made a mistake. Hopefully I didn't. No, I'm pretty sure all of them were okay. The answers look kind of familiar, right? I see the answer should be negative 6. So I hope we get a negative 6 here. All right, and so we get square root of x plus 10 is equal to 2. Again, we're going to square both sides now that we have the radical by itself. And x plus 10 is equal to 4. And we're going to subtract 10 on both sides. We're going to get x is equal to negative 6. But that's what we were supposed to get. Happy days. All right, please feel free to look at any of these things again. I would ask for a new packet or print out a new packet and just try it yourself. And again, this is just the equation portion of the final. And also, so, basically all I did was just have, it's going to be 10 equations. Okay, so you make the judgments of what you want to focus on. Alrighty, and what you want to write the notes on. Have a good one, everyone.